Good day! We are the 6th group of grade 11 Baltasar, and for our group activity, we will be deriving the standard equation of a parabola opening downward with the vertex at 0, 0.
Seen in the graph is a parabola opening downward with vertex at 0, 0. We define the focus as a point found on the same side of the opening with a distance of a units away from the vertex. Therefore, given its definition, the coordinates of the focus will be at 0, negative a. On the other hand, we define directrix as the fixed line located at the opposite side of the parabola's opening with a units away from the vertex. Therefore, the equation of the directrix will be y is equal to a. Recalling the definition of a parabola is a set of all points in the plane equidistant from the fixed point which is the focus and a fixed line which is the directrix.
Suppose we have P as another point on the parabola with coordinates xy aside from the vertex. Let us draw a perpendicular line from point P to the directrix at point Q. So, the coordinates of point Q will be at xa. Based from the definition of the parabola we recalled earlier, the distance from point P to the focus is the same as the distance from point P to point Q at the directrix. Other parts of the parabola found on the graph are the axis of symmetry, which is x is equal to 0, and the latus rectum, which is a line segment passing through the focus with a length of 4a. For now, we'll focus on deriving the equation of the parabola opening downward with vertex at 0, 0, starting with the equation of the length of the line segment PF is equal to the length of segment PQ.
Given that line segment PF is equal to line segment PQ, we're going to find the equation by using the distance formula, which is d is equal to the square root of quantity x sub 2 minus x sub 1 squared plus quantity y sub 2 minus y sub 1 squared. We will substitute the coordinates of the points from the parabola to the distance formula, denoting the coordinates of P as x sub 2 and y sub 2 on both sides of the equation, coordinates of f as x sub 1 and y sub 1 on the left-hand side of the equation, and coordinates of q as x sub 1 and y sub 1 on the right-hand side of the equation. By doing this, we will get the equation square root of quantity x minus 0 squared plus quantity y plus a squared is equal to the square root of quantity x minus x squared plus quantity y minus a squared. Now we will need to eradicate the radical signs by squaring both sides. The equation now will be quantity x minus 0 squared plus quantity y plus a squared is equal to quantity x minus x squared plus quantity y minus a squared.
So after that, we will simplify further the equation. X minus 0 is x raised to the power of 2, which is equal to x squared plus quantity y plus a squared. Since this is a square of a binomial, we will use FOIL method, and the results will be y squared plus 2ay plus a squared is equal to x minus x squared, which is 0 plus the square of the binomial y minus a, which is y squared minus 2ay plus a squared. By using addition property of equality, we will cancel out same terms on both sides of equation. Positive y squared and positive a squared will then be cancelled out. We will transpose 2ay on the right hand side of the equation and let x squared remain on the left side of the equation. The equation that we have now is x squared is equal to negative 2ay minus 2ay. Simplify further and combine like terms, and the equation will then be x squared is equal to negative 4ay. Therefore, the equation of parabola opening downward with the vertex at 0, 0 is x squared is equal to negative 4ay.
That concludes our presentation. Thank you for watching.